This video will cover Trig 1.1 or Pre-Calc 4.1, Part 1 Notes. The topic for this section of notes is going to be radian and degree measures. Radian and degree measures are just two different ways of writing the size of an angle. And so we're going to start off today by talking about how we draw angles, and then we'll move into actually looking at degree measurements versus radian measurements. So to make sure we all draw our angles the same way, we're going to be using what's called standard position of an angle. And so we need to talk about the two different sides of the angle. You'll notice that one side of the angle is right here on the positive x-axis, and that's called the initial side because it's the side that's fixed. It always will start here. No matter what size of an angle we draw, we always start it right there. So that side does not move. The other side of the angle is called the terminal side. That's the side I'm highlighting here in red. That's the side that we will move. So we can move this to the first quadrant, we can move it to the second quadrant, or third or fourth quadrants if we need to. So right now we have an angle that is drawn in the first quadrant. The two different types of angles that we're going to draw are going to be positive or negative angles. And when we look at a positive angle, the idea with a positive angle is that it's opening counterclockwise. So for example, this may be a 50-degree angle. And it's opening counterclockwise, so I know that it's positive. On the other hand, if we look at this example down here, we've got our initial side, and notice that our angle is opening downwards or clockwise. And there's our terminal side. So this is going to be a negative angle. Now I know it's going to be more than 90 degrees, but not yet quite 180. So I'm going to guess that maybe this is a negative 130-degree angle. So this is just examples of how to draw angles. So we want to make sure we always start on the positive x-axis. That's where our first initial side is. And we draw our angle in the correct quadrant based upon the size that we are given. And so this was just two examples of, a positive one versus a negative angle. So the next concept I want to talk to you about is looking at some specific angles when we draw them. And those specific angles we're going to talk about are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So what we have here is an XY axis. And if we were to draw a 0-degree angle, we'd start off by having our terminal side here. I'm sorry, that's our initial side. And that would be 0 degrees right there. For each time that I move to one of these lines, so for each quadrant that I go through, I'm going to be moving 90 degrees. So straight up here would be 90 degrees. When I move down this way, this would be 180. When I move down here, that's 270 until I make one revolution around the circle, which is 360 degrees. So that shouldn't be anything new to you. You should have, in the past math classes, you should have talked about measuring angles, and you used degree measurements. What we want to talk about now in this section of trig or pre-calc is what is a radian measurement. Well, a radian is basically, 1 radian occurs when the arc length is the same as the radius. Well, what does that mean? We'll get to that in a minute. But a radian is just a way to write these degrees as fractions. So we're going to write them as fractions in terms of using pi with it. So 0 degrees is the same as 0 pi. That would be our measurement in terms of radians. And if I'm thinking about going around my circle, when I get up to 90 degrees, we have pi over 2. 180 degrees is the same as pi. 270 degrees is the same as 3 pi over 2. And 360 degrees is the same as 2 pi. So all that a radian is a different way of writing a degree measurement. It's a way of writing it as a fraction using pi. So these would be the common pi measurements that we would be talking about. We're obviously going to be talking about more, but for right now these are going to be the common ones that we're going to be dealing with. You can also change radians instead of writing them as fractions to decimals. So if you just get out your calculator and type in 0 pi into the calculator, you're going to get 0 as an answer. You type in pi over 2, because pi is the same as 3.14. You divide that by 2, you get 1.57. Pi is 3.14. 3 pi over 2 would be 4.71, and 2 pi is 6.28. We will tend to, in this class, deal with radians like this. There will be some occasions where we will use the decimal equivalents of a radian, but most of the time we're going to be using this way for listing out our angles instead of using degrees. You need to be comfortable working back and forth between both of these, and that's kind of what the rest of this section is dealing with, is how do you change from degrees to radians. There's a specific way that we get these values, and we'll talk about that a little bit later on in the next video. So if you want to visualize what does a radian look like, we talked about that the length of this entire circle here is 2 pi, which is the same as 6.28 radians. So on the unit circle, this length here matches this exact length here, this arc length of 1 radian. That's basically what a radian is. So this distance is the same as this distance. And so if we think about complete circle, if we have 6.28 of those, you know, here's 1, then here's the second length, there's your third length, there's your fourth, there's your fifth, there's your sixth, then you have this just this little bit extra, that's the 0.28. So if you add those all up, that's how they're getting the 6.28. So the next topic we're going to talk about in this section of notes is coterminal angles. Coterminal angles are simply angles that share the same terminal side. So angles that share the same terminal side. So let me show you with an example. So you notice over here we've got an angle already drawn. Let's just take a guess and say that this is a 30-degree angle. So if I was to draw just an angle starting here from my initial side going up there, that'd be 30 degrees. Now what I could also do is I could choose to draw an angle that goes all the way around the unit circle once and then back up to there. And we'll call that one the blue one. And since all the way around is 360 degrees, plus then I went 30 degrees past 360, we would say that this is 390 degrees. 360 plus 30 degrees makes 390. So 390 and 30 are two different angles, but they're considered coterminal because they're both sharing the same terminal side. So that's what a coterminal angle is. You can have positive or you can have negative coterminal angles. So if you're trying to find coterminal angles, all you need to do is add or subtract 360 degrees from the angle that you're given. If you're given the angle in radians, then you would add or subtract 2 pi, since 2 pi and 360 degrees are the same measurement. So if I want you to find coterminal angles with pi over 6, you simply take pi over 6 and you add 2 pi to that. I'm going to add to get the positive one, and then what I'll do is do pi over 6 minus 2 pi. Now here's the tendency. A lot of times students want to grab the calculator and add this in the calculator. If you're going to use the calculator, then really what you're doing is you're taking the fraction 1/6 and you're adding 2 to that. And then you'll just plug the pi back in at the end, but not in the calculator. So I know that together this makes 2 1/6. As an improper fraction, that's 13/6. And then you just tag the pi back in the numerator. If you try to type this into the calculator and then change it to a fraction, because pi is an irrational number, it won't work for you. So you have to not put the pi part in the calculator. So if we're doing it for the negative one, we would do a 1/6 minus 2. And again, if we think about this algebraically, I know that 2 is the same as 12 over 6. So I can subtract these fractions now. I'd get negative 11 over 6. And then we just put the pi back in the numerator. So if you were to take the time to plot pi over 6, 13 pi over 6, and negative 11 pi over 6, and draw that, they would all lie in the same position. They would all lie on the same terminal side, so therefore they're coterminal. A lot easier to deal with when you have the angle already in degrees. You just simply add or subtract 360 degrees. So 30 degrees plus 360 degrees makes 390. Again, that's how I got this example up here. And 30 degrees minus 360 degrees to get the negative would be negative 330 degrees. And so those would be my answers for coterminal angles that are positive and negative. So again, the rule is, so I might highlight this if I was taking notes. To find coterminal angles, you simply add or subtract 360 or 2 pi, depending on what you're given the measurement in. This next topic we're going to talk about is something that we first introduced to you in geometry class, the idea of complementary angles and supplementary angles. Complementary angles are two positive acute angles that add up to be 90 degrees. Now, since we're dealing with radians also in this section, instead of just saying 90 degrees, we could say pi over 2. So two positive acute angles that add up to be 90 degrees or pi over 2. So if I ask you to find the complement of pi over 6, basically what I want to know is what angle, so I'll put a question mark, plus pi over 6 is going to get me to pi over 2. So if you think about this, writing this as an algebraic expression, instead of putting a question mark there, we could actually put a variable. And algebraically, all we would have to do is subtract pi over 6. Again, if I'm going to plug this into the calculator to do, I would be taking the fraction 1/2 and subtracting 1/6. And I shouldn't really need the calculator for that, because this is 3/6. So 3/6 minus 1/6 is 2/6, and I know that that's 1/3. So instead of writing it like that, I need to put my pi in there. So it would be equal to pi over 3. So if you take pi over 3 and add pi over 6 to that, you would get pi over 2, or 90 degrees. Now, if I'm asking you to find the complement of 30 degrees, it's really easy to do that. You simply just take 90 degrees and subtract 30. That's essentially what I'm doing over here, is I'm taking 90 degrees, which is pi over 2, and I'm subtracting pi over 6. I just wrote the algebraic expression to show you what I was doing. You don't necessarily have to write the expression. You can just do 90 minus 30 and get 60 degrees. So that's how you find the complement. You recognize that complements add up to be 90 degrees. Now, if we're dealing with supplementary angles, the definition for supplementary angles are two angles that, instead of adding up to be 90 degrees, would be two angles that add up to equal 180 degrees. So in other words, form a straight line. That's what 180 degrees is. And if we're thinking about this in terms of radians, we know that 180 degrees is the same as pi. So it'd be two angles that add up to be pi, or two angles that add up to be 180 degrees. So if I want you to find the supplement of pi over 6, then you could write the expression some angle plus pi over 6 equals pi. Or, probably easier than doing this would just be to take pi right away and subtract pi over 6. And if we're thinking about doing this in the calculator, you can't plug the pi's in. You would have to do, there's an imaginary 1 in front of this. You're going to do 1 minus 1/6. And I hope you don't need the calculator for that, because 1 minus 1/6 is 5/6. And so we put a pi with that, and we find that the supplement of pi over 6 is 5 pi over 6. Because pi over 6 plus 5 pi over 6 equals pi. The supplement, again, two angles that add up to be 180 degrees, so it would be 180 minus 30, and I get 150 degrees. So you notice this time they don't have to be acute angles, because we're dealing with supplementary angles, which have to be more than 90 degrees. So we don't deal with acute when we talk about supplementary angles. But for complementary angles, they have to be acute angles.